Hi, grade 10s. We're going to move into the next module here where we're going to look at the law of conservation of mass. So I'm going to split this video, these videos just into two parts. I'm going to do one part where we review how to count up atoms and look at how many different ratios we may have if we've got more than one molecule, really just to get more practice at it. And then there's a couple of things we'll review also from grade 9. The second module will be about the law of conservation of mass. Okay? So I know that you can't print everything at home, and I don't need you to. What I would want you to summarize from this note that says gas test revisited is something just that I've got written right here about the states of matter. And then on the back, it is the explanation of what happens for each of the gases that you want to remember, be familiar with, okay? What are their tests, the positive test for each of them would look like. So if you have a balanced chemical equation and you have an S written beside a compound, that means that it's in a solid form. So here, for example, I've got some baking soda, that's solid sodium bicarbonate, and you can refer to that as an S. If I had a beaker filled with just some salt, okay, this would be sodium chloride as S, state, solid. If I had some sodium chloride and I added it to a beaker filled with some water, this is where you get into the state that is aqueous, because now what I'm doing, take a minute here for this to dissolve, now I've made a solution. So the little tiny subscripts of AQ, that refers to aqueous in chemistry, and it means that it's in a solution. It means it's dissolved in water. Those ions are still available, but we don't say that this is liquid. The only one we ever use L for is water, H2O, pure distilled water. This is in a solution, so we say those ions are aqueous. Okay, that's one thing from this handout that I want you to summarize. The other thing you can have a look at on the bottom, though, is you've got a balanced chemical equation here for a reaction that you can actually do at home. And I'm going to talk about this in the second video because this is a reaction that I want you to give a try to, and I want you to see what's going to happen. Okay, so if you've got sodium bicarbonate, which is our baking soda, that's this compound right here. The formula for baking soda is NaHCO3, sodium bicarbonate. That's the word, and there's your chemical formula. I'm going to add some vinegar to my sodium bicarbonate. So I'm actually doing a chemical reaction here. Our vinegar is CH3COOH. Its other name is acetic acid, okay? We would buy this in a big concentrated jug and I would dilute it down. Vinegar is only 5% acetic acid. And so can you see here that this is acetic acid in a solution with water? And so I can write aqueous there beside it. When I add the vinegar to the baking soda, you're going to end up with a chemical change. How do I know that? Well, you can see that something new is formed. You're going to be able to see the gas bubbles coming out. And then the question would be, what gas actually gets produced? Now, you look at the atoms that you've got on the reactant side, and how do you know? What if it makes oxygen gas? There's oxygen there, isn't there, on the reactant side? So maybe it could make some oxygen molecules on the product side. I also see hydrogens on the reactant side. It could make hydrogen gas. It actually makes carbon dioxide gas. So if I had an apparatus in my kitchen here, I don't, but if I did in the lab, I could collect some of that gas and then test it. And then your question would be, how do you know which gas it is that's formed? You would do the gas test for the gas that's formed and being able to identify it. Now we know that it's carbon dioxide. We'll review that test. Here's what's going to happen. If you were to take the mass of this and the mass that you're going to react ahead of time. So let's say I've actually got a little bit in my graduated cylinder. Okay, so I have a specific volume, a specific mass. I could get the mass if I put it on a scale. I could also get the mass by using the density. And then I've got a particular mass here. If I take the mass of all of these two compounds in total, that would be the mass of my reactants. The mass of the products is going to be the mass of everything on this side of the equation. So if I could take my reactants, react them together, and then put this on a balance or a scale, if you've got one at a kitchen scale at home, you can do this experiment, you'd be able to figure out the mass of the gas that was produced, because this is not a closed container, right? If I kept it closed, the mass would be the same. But if I kept it open, the gas is going to escape. So I could figure out the mass of the gas that escaped by simply taking the mass of my reactants, taking my mass of the products, and find the missing mass. Maybe you even did this experiment in grade 9. It's kind of a grade 9 experiment. So here we go. I'm going to add my vinegar to my specific amount of baking soda. It is bubbling away. Okay, I'm going to make sure that I get all the reactant to react that I had used. The gas is now completely escaped from my reaction. What do I have left? I do have a bit of sodium bicarbonate still left over because I didn't have enough acid for it all to react. But you can see that what my product is water in the liquid state. Sodium acetate is in here. And then the missing mass is going to be the carbon dioxide. Okay, so that's a chemical reaction. There's a chemical change. You have evidence that a chemical change took place. And what happened at the molecular level? Well, the bonds that were inside of those reactants broke. Atoms got rearranged and new bonds formed. All of the number of atoms I had on one side is equal to the number of atoms on the other side. If I counted them all up, that's what we're going to be doing. You can see that they are equal on each side, and that's what we call a balanced chemical reaction. Okay? Now, let's go to the next page. And on the back here, it gives you a summary table of all of the gas tests. So this is what you do want to summarize just for your information, because this is general knowledge now, okay? I know you learned it in grade 9. We practice it in grade 10. We do it in grade 11 and 12. This is common knowledge, okay? What is the gas test that you use? How do you identify these three kinds of gases? So again, I've got oxygen. Okay, if I have oxygen gas and only oxygen gas, and I take a wooden splint, so a popsicle stick, they look like those, like a thin little popsicle stick. If I put it in a candle and then put it into a test tube and there's oxygen there, what'll happen? The glowing splint will reignite and it'll burst into flames. That's my gas test for oxygen gas. What's the next gas? The next one is my hydrogen gas. I'll put that in my beaker here. And now if you want to identify hydrogen gas, how do you do that? You also do a flaming splint test. So instead of just having it glowing, right, the first one for oxygen, you would get the splint in, blow it out, and then it's still glowing. And if you expose it to oxygen, it will burst back into flames. This one's a little bit different. This one, I'm just going to take my splint, I'm going to put it in the candle, light it on fire, I'm going to stick it into my test tube, and it will have a characteristic excuse me, a characteristic squeaky pop, and that is when it bursts into flames. You get a small explosion when you test for hydrogen gas, okay? What's the third gas? The third one is you can do a flaming splint test. This time you put it in again if it's flaming, and if it goes out, well then you've got carbon dioxide, because carbon dioxide will actually extinguish the flame. There is a third test for doing an identification of carbon dioxide, and that is if you use lime water. Lime water is a compound that's called calcium hydroxide, and calcium hydroxide in a solution, aqueous, in the presence of carbon dioxide gas will actually form calcium carbonate, and that's a solid precipitate in water, and that calcium carbonate actually makes that lime water look cloudy. It looks like a white precipitate is actually in there. Actually not too far from this right here, actually, something different, but it gives the idea of what it might look like. Okay, those are the three gas tests that you want to remember. Next, you can go through and do any more of those if you'd like. What I want to get into right next is just a quick review of how you count the atoms in compounds. So you're welcome to go through and fill in the next few sheets if you'd like. If you even have things at home where you can make molecules, what I would do is I would suggest that you find marshmallows, or maybe you've got gummies, or maybe you've got jujubes, maybe you've got pieces of gum, maybe you've got Play-Doh at home. Anything like that. You could even just draw a picture, okay? You want to be able to visually represent what the atoms look like in a molecule. So in the lab, we would have built things. We would have built hydrogen molecules. We would have built oxygen molecules and shown that I had enough hydrogen and atom molecules, for example, on this side to build the number of molecules of water that are on that side. And what you want to remember, it's the bonds inside the molecules on the reactant side that break. Step number 2, the atoms rearrange, and step number 3, new bonds between the atoms form new compounds, and that's a chemical reaction. Okay, so again, it's taking our terminology from the last module and keep talking about the same thing. We're just building our understanding. So with these chemical reactions, you can go on. And I've got all the solution sets right here. Maybe just do a couple of examples of these because it's not too tricky. But if you want to build and you want to have fun, go for it. Okay? Do as many or as few as you'd like. Once you get to the bottom, I want to review our terminology again with our atoms and molecules, and then we're going to lean this, or this is going to take us right into the next module. We're going to learn about the law that states that all of the atoms on one side have to be the same number and type of the atoms on the other side. Okay, now I built this one right here sitting in the kitchen, and I want to just show you what that would look like if you had our molecule kits and you could take them apart. Okay, so for this one right here, I want to show that you've got one molecule of methane reacts with 2 molecules of oxygen gas. They react to produce 2 molecules of water and 1 molecule of carbon dioxide. So you can see that as I said that, that's the word equation. There below my molecules here is our balanced chemical equation, and you want to just practice counting. Do I have the same number and type of atom on the reactant side as I have on the product side? Okay? And in my solution set, you see that I've got that as well. That's your summary from this. That's your summary from this molecule demo that I have right here. Okay, so that's it for this part. And the second part, I'm going to talk about the law of conservation of mass.